and I'm going to turn it over to Dr. King to get started. So I'm going to stop sharing, Kristen, and then let me pass this to you. So you should be able to share your screen.
Okay, everyone, I'm going to stop my video, share my PowerPoint here.
And just a reminder, while she's loading up her PowerPoint, if you have questions during the presentation, post those in the chat. I'll monitor that, and then we can, towards the end, when there's time for questions, if you want to voice a question, then you can raise your hand, and I'll monitor that as well. Thank you.
Thanks. So I just want to do, everybody can see the PowerPoint, everybody can hear me. Do a quick check.
Yes.
Okay.
Yes.
Thank you. So thank you for the kind introduction. I also like to thank the Southwest Center for Occupational and Environmental Health for inviting me to speak today at this IH seminar. So just a little bit of background on me. I've been here with the University of Texas Health Science Center at Houston within our EHS department for about 10 years. That time is split between the biosafety side and then implementing and developing our clinical safety program. During that time, I was going to the School of Public Health here at the University of Texas Health Science Center. And this project kind of came through that schoolwork, but also working with our some clinics around in the area. So what we're going to talk about today is this project I did in 2019, which was the assessment of outpatient clinic room ventilation systems, and then the possible relationship to disease transmission. So the agenda for today's presentation is to go through that assessment, talk about any changes that have occurred to the corresponding regulations since the project concluded and was published, and how this project relates to the COVID-19 pandemic. And then we'll have some time at the end for questions. You can also interrupt me at any point with any questions if you have them. So the idea for this project was a culmination of several trends that were happening in healthcare. So the first is a trend away from inpatient or hospital-based services towards outpatient services. A few of the reasons for this trend towards outpatient services is that there's actually a cost benefit for operating an outpatient. We have an aging population, so it's more convenient to have outpatient services rather than have a centralized hospital for people to travel and such. And then having advanced technologies that are allowing for more procedures to be done outside of the hospital. So outpatient services can actually be in a variety of different settings. So we have outpatient departments that are a part of a hospital, ambulatory surgical centers, freestanding urgent care and ER centers. And then you have retail clinics and such as physician offices. These last two are really important for this discussion because these are in usually converted retail space. So additionally, there's an increased range of services that are being done in our outpatient services, including minor surgical procedures. So some of these procedures can also be aerosol generating, and this can create an increased risk for both the patients and the workers. Risk may increase due to the nature of the outpatient visits. Generally, in outpatient visits, there may be little known about the patient's status of infectious disease, whether they're coming in for a specialized or surgical procedure as well. Excuse me. So unlike hospitals or ambulatory surgical centers, physicians' offices are usually less regulated and inspected. Generally, they are not required to be accredited by a joint commission or some kind of other accrediting agency. And this can lead to procedures being conducted in clinic spaces that really just aren't set up for certain types of procedures. So, sorry, I had a little cough. Outpatient clinics are built or reconfigured based on city codes. So they follow the International Building Code, or IBC, and then the National Fire Protection Association, NFPA codes. So these are primary construction codes, and they classify buildings based on the ability of the occupants to evacuate an emergency rather than the real use of the building or the space itself. So for hospitals, this all aligns with the Facility Guideline Institutes, their guidelines for design, building, and construction of various healthcare facilities. So for hospitals, NFPA and FGI really kind of match up. But the FGI defines an outpatient clinic as anywhere where outpatient services are being performed, whether they're in a hospital, freestanding, or in a multi-use building. So these FGI definitions and guidelines are then incorporated into the collaborative ANSI ACHRAE standard for ventilation of healthcare facilities. This is standard 170. And for the purposes of this study, we were using the 2017 version. We'll come back later to that at the end of that because it has been updated since this study and publication. So really their question was, since these fire codes primarily drive our construction, it was really uncertain to us whether the ventilation standards and the 170 standard are being incorporated into outpatient clinics and these modified retail spaces. So when we think about 170, they do really talk about ventilation requirements as minimums that provide control for the control of environmental comfort, asepsis, and odor. So when we look at the primary construction code, the NFPA, they classify outpatient clinics or these retail type clinics as business or group B occupancy. And that's based on generally there is less than 5 people that are incapable of self-preservation in the case of an emergency at one time. So meaning unlike a hospital or really an ambulatory surgical center, most patients in our outpatient services or our outpatient clinics will be conscious and they'll be able to evacuate themselves in case of a fire. This group B occupancy is also used for transaction type services such as post office, banks, some civic administration offices, and things like that. These generally have less stringent fire codes. They are simple mechanical and electrical components. They usually have lower ventilation standards. All of this makes them easier and less expensive to build and maintain. So when we're talking about ventilation, the primary unit that we're going to be looking at is air change per hour. So this is just an air exchange rate. It is the amount of times all of the air in the room is replaced with completely new air within an hour. So the table off to the right is the minimum total ACH for the 170 standard. Now the 170 standard breaks down ventilation requirements based on what the room is used for. So for a general exam room, this is used for exams as well as vitals. It is the same for ACH, so the same for ACH as the group B occupancy standard. However, when we start looking, the ventilation rates start to increase with different types of treatments or procedures, specialized procedures. A treatment room was defined as any exam room that then would be used for additional treatments or procedures. So that's pretty vague of a definition. That would be a 6 air change requirement. A procedure room is a room that is not required to have a restricted environment like an OR, but would involve the use of sterile equipment or sterile fields. And that was requiring a 15 air change per hour. And then we started looking at aerosol generating procedures. These are generally recommended to be done in negative pressure isolation rooms. These have a 12 air change per hour requirement. These are typically not built into outpatient physician offices but would be used in airborne transmission precaution. So the literature review at the time revealed several articles where low or improper ventilation resulted in the transmission of airborne disease in the outpatient as well as the hospital setting. So we had one where the transmission of measles was observed in a pediatric clinic, and they actually had measured the ACH as 4. Also had transmission of tuberculosis during sputum inductions with a measured ACH of 0.5, as well as some additional transmission of tuberculosis with low, quote, lower improper or lower than standard in the hospital setting. There was also some additional transmission of respiratory infections, and this was observed in an Army barrack where we had a 3 ACH. Several of the authors also noted a concern for energy efficient building designs and recirculation being a risk factor for disease transmission. So this study was to examine whether outpatient clinics that were operating in our operating in a business occupancy setting and conducting procedures, if the rooms where they were conducting those procedures had ventilation rates at above or below the threshold for the ANSI ACHRAE standard 170 for ventilation in healthcare facilities. And then we wanted to look whether lower ventilation rates and building characteristics increase the risk of transmission of infectious disease. So the aims of the study, first we had to categorize the rooms within each clinic based on the services provided, and that was done by asking the clinic staff. Aim 2 was to measure room ventilation rates, directional airflow, and air mixing in the clinic rooms. I'm so sorry. Aim 3 was then to take those measurements that we did for ventilation and compare them to the national standards in the 170 standard. And then Aim 4 was looking at building characteristics and measuring their association as determinants of the ventilation rates. And then Aim 5 was looking at estimating the risk of infectious disease transmission based on our ventilation rates that we measured. And graphing these as part of the Gametoni nucci equation and model. So the study included 105 outpatient clinic rooms. This was over 22 clinics. Not every room within the 22 clinics was part of the study. We had exam rooms that were used for general exam only. That made up 24% of the rooms in our study. Then we had rooms identified as a treatment room. So these were the majority of our rooms at 60%. And then of what was going on in those treatment rooms, most of the procedures were aerosol generating procedures rather than minor surgical. And then we had rooms identified as procedure rooms were 16% of our study population. And that was relatively split between aerosol generating and minor surgical. So a note on this, the procedure rooms were generally labeled and identified as procedure rooms solely, and then our treatment rooms were generally exam rooms where additional things were going on. You'll see on the right here, we kind of talked about what we classified aerosol generating procedures versus minor surgical. So what we had occurring in the clinics was, as far as aerosol generating, was suctioning of body fluids or air passageways, nebulizing medications, and sputum induction. Whereas with the procedures, we had a wider range of activities occurring from skin biopsy and dermatological procedures, incision and drainage. We had some colposcopy and vein ablation. And then below that, you'll see the breakdown of the clinic specialty. So about half of the clinics were classified as, they were designated as multi-specialty, meaning general practice, family practice, and then multiple specialties rotated through those. And then we had specific specialties of pediatric, colorectal, dermatology, ENT, women's, and CV surgery. So moving on to the results of our study, what we found, what we wanted to note first off was that 15 of the clinic rooms did not exhibit a continuous airflow. Rather, these cycled on and off. This might have been due to some energy conservation initiatives for the building. So when this occurred, air measurements were conducted when the air came on. I was really unable to determine whether this was due to just the zoning of the building, if there was these energy conservation initiatives in place for the building, or if there was actually a failure of our ventilation system. But noting, we'll kind of talk about the types of buildings later, but noting that we generally had 3 types of buildings that our clinics were in. The ones that had this issue were in the shopping center and standalone buildings. The ones that did not have this problem were in medical office buildings. So we'll kind of circle back to that and discuss that again. We also looked at diffusers just as kind of an observation. So supply vent diffusers were located in the room ceilings. They were either the 2 foot by 2 foot square or the slot diffusers. So the majority of the clinic rooms had the square diffusers, but all of the slot diffusers were located only in the medical office buildings, whereas the square diffusers we saw in all the different types of buildings. So slot diffuser units, really they have an advantage because they are an unobstructive way to supply air to the room. They're designed to blend into the surrounding finishes. It allows them, they generally have or provide a higher level of control over the design and the layout of the space while still providing the same supply of air. The downside to the slot diffusers is they're a little bit more costly in terms of upfront materials when they're being put in versus the standard square or circle diffusers. Measurements were taken in each clinic room. So air change per hour was calculated for each room by measuring CFM or cubic foot per minute from the room air supply with the Alnor bolometer. Pictured here is the hood for the square diffuser, but we also had a hood for the slot diffuser, which were used with the corresponding diffusers. An average of 9 measurements were taken. So we did 3 measurements every time we went into the clinic. And then that was done over 3 days. And then we used the calculation with the room volume to achieve our air change per hour number. CO2 was also measured to determine a relationship to air change per hour. This was done at the same interval as the CFM measurements, and that was with the Q-track. And then we had did some airflow observation. So we generated a puff of smoke with these Draeger air current tubes, and we did that at the supply vent, at the door, and then at the exam table. The exam table was trying to emulate, if you will, a patient's respiratory, any kind of thing that they would be respiratoring out. And then we also calculated air mixing by air mixing times by really just generating 1 puff of smoke and timing how soon the smoke dispersed. So this is some general information about our air change per hour measurements. So again, you'll see the 3 kind of room types. So exam, treatment, and procedure. And then the procedures, the treatment procedures broke down between aerosol generating and minor surgical. Mean and median ACH was calculated, We tended to have a little bit of our data statistically didn't have a normal distribution. So we used the median ACH for some of our statistical analysis. But you'll see that for all of these, whether the 3 different room types, as well as the rooms used for various procedures, there's not anything that stands out. We found that additionally in our statistical analysis that we had no statistical significant difference between the ACH between either the room types or the procedure types. CO2 ranged from 350 to 1,011 parts per million. The mean CO2 was around 600 parts per million. All clinic rooms were within the acceptable CO2 values for a typically occupied indoor space with good airflow. We had 2 that were just above 1,000, so just out of that range. And then what we found with our statistical analysis was that we found a relationship between air change per hour and CO2. So for each 1 unit increase in CO2, the ACH would increase by 0.008 units. So talking about air mixing, so this is how soon or the timing of the clearing of that smoke. So for 10% of our clinic rooms, we observed good air mixing, meaning that smoke dispersal within 10 seconds. For 28% of the rooms had fair, meaning that smoke dispersed between 11 and 20 seconds. And then 62% of our clinics demonstrated poor air mixing, smoke dispersal greater than 20 seconds. This trend was across all of the room types. So there wasn't any trend that any particular room showed any leaning towards any type of good or versus poor air mixing. And that we found that with a simple linear regression that we had a statistical significant relationship between our air change per hour and this air mixing rate. So that for each 1 second increase in air mixing time, which higher increasing time means poor air mixing, that our ACH actually decreased by 0.4 units. We also looked at that directional airflow. So again, we had the 3 different sites that we generated a puff of smoke and watched where it was moving towards. So when we did a puff of smoke at the supply, 68% of the clinics had movement towards the door and 20% had movement towards the patient. When we generated the puff of smoke right at the door, we saw an inward movement into the room. And then when we generated this puff of smoke kind of at the patient table, again, kind of simulating a patient respiratory, if you will, 46% moved towards the door, while 32% really kind of lingered around that area and didn't have any swift movement. So that would kind of indicate that was going to linger by the patient or linger by the provider. However, we saw no significant association in this airflow direction at any of these 3 locations and any of those 3 room types, exam, treatment, or procedure. So just to orientate you to this picture, this is an overhead view of a typical outpatient clinic room. So there's a door, bed, sink, desk over here, and then the supply air in the ceiling, and then return air placements could be either A, B, or C also in the ceiling. Now, there's some discussion how in the healthcare that return vents should be kind of at the floor so that we have this downward flow of air that would get greater air mixing. So we're kind of moving air past the patient, past the provider, and then towards the ground. So that's not available in outpatient clinics. Everything's in the ceilings. So what we had was In 63% of the clinic rooms observed, we had supply air here, and then placement of the return air was just inside of the exam door. So this kind of helps explain a little bit of this movement when we see things that are moving towards the door. In that previous slide, it was probably due to the pull from our return air. 10% of the clinics had a return air placement in a B location, which was generally opposite of the door. This was generally close to our supply. So we had this, we're concerned about like a closed loop circulation here rather than if supply is pushing out in this location and we have a longer distance to return, we might have better air mixing and air movement within that clinic. And then 7% of the rooms had the C location for the return air somewhere between supply and the door. Again, we had no statistical significant association between these three return placements in the room types, exam, treatment, or procedure. So now we're going to look at the measured air change per hour and whether those met the standard 170 requirements. So 10% of the clinic rooms that were assessed did not meet the minimum 4 air change per hour for general exam rooms. So this finding was not limited to a specific room type. What we saw was 16% of the exam rooms were below 4 air change per hour, and then 9% of the exam room, or sorry, for the rooms that were used as treatment rooms or procedure rooms were also below this 4. And then 10% of the rooms that were used for aerosol generating procedures and 6% of the rooms used for minor surgeries were below this minimum requirement. So now we're going to look more at each type of room. So of the rooms, again, that were general exam, it's the same number, 16% of those rooms did not meet the 4 air change requirement for general exam rooms under the standard 170. Just to note, this is the same standard, if you will, for general occupation group B, which would be under standard 62.1. Of the rooms that were used as treatment, this treatment includes both aerosol generating and minor surgical procedures, had 39% that did not meet that 6 air change per hour requirement per the standard. And then of the rooms that were defined as procedure, so again, not restricted environments, but using sterile instruments or sterile fields, we had 91% of the rooms did not meet that 15 air change per hour standard. Looking at the room specifically for aerosol generating procedures. So again, these are suctioning of body fluids and air passageways, nebulizing medications, sputum induction. We had 85% of our clinics that were using these procedures, those rooms did not meet the 12 air change per hour. And then of the rooms that were doing minor surgeries, 88% did not meet the 15 air change per hour. Now I have to give it 15 air change per hour is pretty high and maybe out of the range for outpatient clinics. So if we looked at these minor surgical procedures and said, hey, can we classify them as treatment? Only 41% of those rooms would meet that 6 air change per hour. So we still have a pretty high number that would still be out of range. So now we're going to look at building characteristics. Again, we talked about this already, but just to clarify, so we have these 3 types of buildings that our clinics would be within. So medical office building was defined as an office facilities designated specifically for healthcare practices. Shopping centers would be a collection of independent retail space that are kind of connected together. And then standalone would be individual buildings only housing a specific clinic. So 42% of our clinic rooms were medical office buildings. They had a mean ACH of 8.8. They were evenly distributed, or the clinic room types were distributed through that. Shopping center and standalone, they each had 29% of the remaining clinics. ACH for shopping centers was a little bit lower at 6.4. And for the standalone, the ACH was a little higher at 10. But want to note for the shopping center and standalone, we have really a disproportionate of the number of rooms being used as treatment. So more of the room spaces are being used for a greater variety of things. So can we associate any building type with ACH? So of the 10% of those clinic rooms that did not meet that 4 ACH standard, these were evenly distributed between our building types. So our statistical analysis showed no significant difference between ACH and these 3 building types. When looking at the building age, the mean for all of them was about 29 years old. Our medical office buildings were some of our older buildings, or some of the oldest buildings, and the standalone being the youngest, newest built. And so our statistical analysis showed no significant difference in the building age and the building type, or between building age and the air change per hour. We also looked at the number of floors within the building. So most of the standalone and the shopping centers were 1-story buildings. We did have one exception in our standalone we had one building that was a 2-story building. And then really the remaining clinics were in these multi-floor medical office buildings. It makes the data a little bit skewed because we had, while we did see some statistical significance in floors between the building types, I really think it's because so many of the clinics that we observed were in these medical office buildings that had just an overwhelming number of floors compared to our 1-story other units. And then there was no statistical difference between the number of floors and the air change per hours observed in those rooms. The last building characteristic was square footage. So we had a mean clinic size of about 8,500 square feet, ranged between 2,000 and 15,000 square feet. Our clinics within our medical office buildings, sorry, that's all there for you. And then no statistical significance was observed between square footage and the 3 different building types, or between square footage and air change per hour. So moving on from the building characteristics, talking about the Gametoni nucci model. So what we did was took our ACH that we collected and measured during the study. There is published quanta for tuberculosis, influenza, and measles, and our standard respiratory rate, and we graphed the risk of transmission. So the first graph here is for tuberculosis, which has a quanta of 12.7. So what we want to note here is that this line here, this blue line where it says exam, is marking a 4 air change per hour. So if we have at 4 air change per hour, the transmission of tuberculosis to susceptible persons in a room for 15 minutes would be 32%. With time, it would increase. So within it for an hour, it would be 78%. If we increase that to 6 air change per hour, the transmission rate decreases to 22% for a 15-minute exposure, and then would increase to 64% for an hour. If we move that air change up even more for a 12 air change per hour room, we would decrease that for 15-minute exposure to 12%. So just a note that Typically, these rooms with 12 air change per hour are used to provide clinical services to tuberculosis patients in the hospital. So we can definitely see that they are effective in reducing transmission rate. Transmission of influenza is noted here with a quanta of 100. So transmission of influenza to susceptible persons in a room would be 95% at a 4 air change per hour for 15 minutes. If that air change was increased to 6, it would be reduced to 86%. And then if we increased our air change per hour to 12, it would be 65%. And then as transmission rates will obviously increase at or near 100 for over an hour. The last one is for measles. Measles is highly transmissible. It has a quanta of 570. And then we really only see a slight reduction from 100% transmission to susceptible persons at 15 air change per hour. So generally, just to quickly go over the results of our study, we did find several outpatient clinics not meeting the ventilation standards under standard 170. So 10% of our rooms did not meet a 4 ACH for general exam rooms. 39% of rooms used for treatment did not meet the 6 air change per hour. 83% of rooms used for aerosol generator procedures did not meet the 12 air change per hour. And 88% of rooms used for minor surgery procedures did not meet the 15 air change per hour. We saw no difference in air change per hour based on room type or procedure type. CO2 and air mixing rates can be used as indicators of air change per hour. And then no directional airflow was associated with any particular type of room. And again, we had some airflow that was not continuous but cycled on and off. We saw no difference in air change per hour by building type. Our building characteristics were not associated with air change per hour. However, we will note that standalone buildings generally had a higher air change per hour. They were newer and they had fewer floors. Those shopping centers and standalones had more treatment rooms than any of the other, than the medical office buildings. And overall, from our infectious disease transmission models, we found that these outpatient clinics might facilitate transmission rather than protect when our air change per hour doesn't meet these standards. So with these lower air change per hours, we did a little predicting here with our crystal balls, we might have had a problem with the ability to safely perform assessments and care for persons under investigation for an infectious disease, that this might inadvertently increase the risk to workers and spread disease within the clinic. So this was a pre-COVID prediction, if you will, that turned out to play a part in concern during COVID. So some of our study limitations, we did have quite a few limitations with the study. So again, with those clinics that cycled air rather than having it continuous, that might have altered our air change per hour measurements, because we were literally taking a measurement when it came on, and then it would go off for the remainder of they came on for 10 minutes and then would go off for 50 minutes. And so that didn't maybe reflect the air change per hour at any point in time in that clinic room. We had the majority of our clinics being in leased space, so we did not have any access to the main ventilation systems. So we couldn't do any direct measurements for the building. We had the way that the study was designed, we were doing some repeat measurements. So statistical analysis for our building variables may have had some bias due to these repeat observations for building age, floors, and square footage. Many of our clinics share space, so multiple specialties throughout the week go in the same room. So there's a lot of procedures or treatments being done in the same rooms, making them very difficult to classify. And then we would have loved to be able to track real time, but due to the real nature of outpatient visits, it's very difficult to track these nosocomial infections and spread of disease from exposure in the outpatient clinics. If we had that, we could use that to really support our infectious disease risk modeling. So based on some of these limitations, some of the future studies that we could see coming out of this was measuring ventilation in the whole clinic or the whole building. And that would be able to help us really focus in on specifically for the specialty, what their procedures might be for that clinic. We could evaluate every room within that clinic and then do air modeling for the entire building system, looking at HVAC zoning, and then direct measurements from the main HVAC system for the building. Again, we feel like the mixed effects model would be needed for our statistical analysis. And then being able to access any patient records or employee health records would be able to track real-time transmission if we were able to do that. Again, correlating that to ventilation rates, length of stay of the visit, all of those things would better evaluate any real-time transmission. But it's just based on the nature of outpatients, it's really difficult to do. And then to aid in these future studies, a phone application could be made to generate or to calculate the ACH from CFM measurements in room volume. This would allow a quicker time to more real time be able to evaluate each room for any purposes that the room might need to be used for. So again, just talking about how ventilation rates, we did see those go below the standards as we just discussed. The risk of transmission of infectious disease may increase when the lower ACH, there's lower ACH in rooms that are used for more advanced or more high risk procedures. And as far as, although we didn't see any direct correlation with any of the building characteristics we looked at, the newer built one-story standalones generally had a higher ACH. This may just be due to better ventilation control. Overall, the national ventilation standards should be considered when we're developing any of these healthcare settings and factored into clinic design for each room, and including being a part of lease agreements for leased space, and should be assessed by the clinic as they're kind of formulating their flow and what procedures would be done in what rooms. So since the study was completed and published, the ANSI ACHRAE standard 170 has been updated. This was done in 2021. And what they did was for the outpatient healthcare section, they divided it into specialized spaces. These mostly retained the same air change per hour standard. But then they had section 8.2, which is for non-specialized exam rooms. And this reduces the ACH standard to 3 for urgent care, psychiatric, and dental, and then 2 for just general exam use. So if we took this new standard and applied it to our previous data, we had only 3 clinics that would not meet that 2 air change per hour standard, and those were ranged in use. And then we would, if we said, okay, well, let's look at 3 air change per hour, we would have an additional 4 rooms that would be less than 3. So if you just thought of a 3 air change per hour or below, we would have had 7 rooms out of 105. So thinking about those lower air change per hour rates and thinking back to those publications of the literature review that were part of the initial study, we were still seeing some transmission at these lower ACH levels, which still causes us a little bit of concern in regard to outpatients and just really still focusing on the use of the exam room rather than keeping them all the same. So now that we know a little bit or have a little bit more data on SARS-CoV-2, we know that most of transmission occurs in the indoor environments by droplet, possibly some airborne. that our outpatient clinics would have higher exposure risk because they are having close contact with infectious patients. Viral RNA has been detected in the hospital setting, in the hospital settings, but hasn't really been evaluated in our outpatient settings. And that the target for indoor spaces, the ventilation rates would be 4 to 6 air change per hour. There's also been published quanta for SARS-CoV-2 exceeding 100. So if we think of it in a very similar way that we did for influenza, we would see some transmission to susceptible patients. So in general, outpatient clinics followed CDC recommendations, starting out by seeing symptomatic patients outside or at the car. For sample collection for COVID was considered an aerosol generating procedure. If they were seen within a clinic space, the recommendation was that the room would remain vacant for 60 minutes to allow for air change, assuming or based on a 4 to 6 air change per hour by the CDC. So when there was kind of a return to normal operation, air change per hour and airflow assessments were done in clinics, specifically for clinics that were wanting to start aerosol generating procedures again. And that was allowed the identification of rooms that would be the highest ACH to then move aerosol generating procedures into those rooms. This would potentially then reduce the wait between patient time for those rooms, which outpatient facilities, they see a lot of patients. So this was a big factor in getting them back to normal operations. And then moving forward, engineering changes such as having UV in the building ventilation could be used to help with this effort. I've attached a list of references for your review. That wraps up my presentation. I thank you for your time, and I'm happy to answer any questions.
Great. Well, thank you. We do have one question from Osman. And the question is, are transmission rates based on recirculated air or once through? For example, 100% fresh air.
Recirculated.
Okay. Yeah. I had a question, and maybe you could expand a little bit. I noticed you were using a bolometer to measure, the airflows, and so for the measurements of air changes per hour, was there a specific method? I think you briefly mentioned it, but were you doing temperature or carbon dioxide measurements at certain points to determine the amount of fresh air?
Bolometer measurements, were conducted in the rooms. Typically, I was in the room for 15 minutes if we had continuous airflow to do measurements. Really, I visited the clinic 3 different times. It was spread out. It wasn't, it was spread out over a couple of months. During that time, while I was, for each visit, the bolometer reading was done 3 times. So it wasn't a continual, I didn't just stand there with the bolometer up to the vent and did continual measurements. We kind of took it down and to try to recreate as best we could an initial measurement for each measurement. Yes, CO2 was collected at that same time. So it was kind of all done within the same period for each visit.
And I was just curious, did you also look at the percent of fresh air just to get an idea of?
I didn't, that wasn't part of, I didn't look at that as part of a factor in the study.
Okay. Good. We have another question from Dr. Casserly. What was the relationship between CO2 and air changes per hour?
Okay, let me flip back to that slide. Let's see here. I don't want to get the what we found statistically that there by simple linear regression was that the association was as we increased 1 unit of CO2, the ACH would increase by 0.008 units.
I don't think there's any other questions that we have. I definitely see the value of reducing, patient visit times, obviously with the duration being important for, especially for like measles and influenza and COVID. So it's very interesting.
Right. And so previous to this, we just in kind of experience, I can't remember the dates, it's so long ago now. I think it was around 2017 or maybe 2018, there was a slight measles concern around. And so a lot of the same length times between visits, as well as other preventative measures, were put in place. So they do rely on ventilation as part of infection prevention practices.
I mean, I definitely see the value in pre-screening on some of that. And I just know from my own experience, there's a lot of data collection going on in the exam rooms, and so that can lengthen maybe some of those visit times in the room. Whereas it seems like some of that information could be collected, prior to the visit, you know what I mean? Or, well, actually, before they actually visit, that there might be some value there in the field, just kind of reducing amount of time patients spend in the rooms overall, if that makes sense.
Yeah, and I just wanted to make one clarification. These clinics were not directly associated with the university. It was a collection of outpatient clinics in the greater Houston area. And so, but I said our clinics because just referring to the clinics that were part of the study.
Wonderful. Well, thank you, Dr. King. And I think
Thank you so much.
We're ready for the next presenter.
All right. Thank you, Dr. Phelan, for moderating, and thank you, Dr. King, for that wonderful presentation. So we're just going to take a few minutes here. Nancy McClellan is joining us by phone, and I'm going to run her slides. So thank you, Nancy, for bearing with me, and sorry about those technical difficulties. WebEx sometimes just doesn't work. So give me a few minutes to pull up your slides, and then I'll do a short introduction, but let's test your audio while we're waiting. So Nancy, if you can unmute yourself and just say something, we'll test that.
Hi, can you hear me now?
I can.
Excellent. I'm glad we have some connection other than our phone calls and text messages this morning. So good morning, everyone.
Definitely. So good morning. Okay, Nancy is joining us today as she's the principal industrial hygiene expert and CEO at Occupational Health Management. And she currently serves as the chair of the University of Michigan Graduate School of Public Health on their external advisory board. And she's on the AIHA Executive Board of Directors as the treasurer-elect. So Nancy is talking today about building a globally applied risk assessment tool. And can everyone see the slides I have pulled up for her?
Yes.
Thank you. Okay, Nancy, you can take it away. I have your first intro slide pulled up, so I'm just going to mute myself and follow your lead. You just let me know if you need anything.
Okay, well, thank you for the introduction, and I'm happy to be here with all of you. And what we're going to go through today is not only applicable to the examples that I have, but I know all of you have been living the pandemic dream. If there's ever been a time that our profession's been called to the forefront, it's been recently, and risk assessment has been part of that process too, because even what OSHA called for in the emergency temporary standards, risk assessment became something that came to the forefront. So what I'm going to take you through today is an overview of risk assessment and take you through some tools. My experience has been not only as a consultant, but also working for some large organizations where somehow you have to wrap your arms around the larger picture of what you're dealing with on a daily basis. And so risk assessment becomes one of the best things in our toolbox in order that we could do that from a higher level. So if you want to advance it to the next slide, slide number 2. So today what we're going to do is talk about risk assessment purposes. We're going to talk about an anatomy of a tool to give you an idea of what it looks like so that you can go back and design your own. We're going to talk about the key performance indices that come out of that process that become a really good way to talk to the higher ups in your organization and talk their language in making those business cases. And then we're going to talk a little bit about the challenges that are part of doing risk assessment. Hopefully all of this will then feed into the next lecture, which is Brad's on control banding. So next slide. What we need in organizations is an organized and a consistent means for looking at worker risk. We need to have a common language through our organization that everyone can understand and get on the same page. And the solution is often a software-based risk assessment tool. Software becomes the next generation. Often what these look like is an Excel spreadsheet on steroids. All right, that's usually where we all start in order to build these tools. But we need them to qualitatively and quantitatively begin to assess and give a rating system to those potential exposure risks for whether it's a hazardous agent that's a chemical or it could be a physical agent, and in the pandemic's case, it's become biological agents. And what they do is they create a common platform to give us that common language and uniformity in order that we can report to our peers in EH&S, report to people that we're responsible for, and then also report to management in that data output that we create. Next slide. The reason we want to do this is because we need to engage in a continuous improvement cycle in industrial or occupational hygiene. And a lot of people seem to appreciate the simplicity of putting this into the language that our business partners and our organizations always speak. They speak about the Deming wheel, the plan, do, check, act. All right, that's a common language. And it gives us a way to translate that into industrial hygiene, which is anticipate, recognize, evaluate, control, and prevent. So when we talk to our management, and we talk to people who are responsible for the other aspects of our businesses, to explain to them that part of our planning is to anticipate and recognize hazards, they start to get it. And when we add risk assessment as part of that planning, we can then save money for the do and the check part of a continuous improvement process. That speaks their language. When you can say, look, if I do this on the front end, I can save money on the back end in that continuous improvement process, everybody else in our organization starts to get it. So adding risk assessment is really about not only doing our jobs, but also speaking a language that everyone else can appreciate. And I always invite people, please steal my slides, steal my diagrams, take whatever you want, you have my permission. So I'm pretty sure that my slides will get made available afterwards. So if you like this, borrow it, steal it, reproduce it, whatever you want. Next slide. So why bother with an assessment process? What it does is it can provide root cause revelation. All right, we can start digging back as to what is the real problem if we start looking at the larger sense of the data. It also helps us communicate out those risks versus potential loss information that's often needed by management at site, national, and global levels. So this isn't something that just speaks to one site. It helps you tie in all of your sites regionally, nationally, globally, in order that you get everybody on the same page and you can communicate what the problems are and what the potential solutions are. It also makes an IH program more informative and effective because now you're giving it key performance indices, which we'll cover later in the lecture. And it just gives you a more focused, efficient, and effective evaluation and control program so that you're not only effective, but you're also saving money later on. And we'll go over that more in a few slides. So next slide. So what is risk? Risk, classical definition, is severity times likelihood. We have factors within severity, such as the hazard's toxicity, what its potential health impacts could be. We also have for severity the concentration and intensity of exposure. We also have to consider environmental conditions that impact its severity. And then also the individual's health status can make a big difference. The likelihood factors include frequency of exposure and duration of exposure for likelihood of exposure. Next slide. So when considering risk, we look at the possibility. What we could do is talk about, instead of doing a group exercise here, because I'm not sure that there's an opportunity to break up into small groups in this context, is think of your industry, all right? And what I'd like for you to do is jot down a few items that touch upon the severity and the likelihood within your industry. And I know that a multitude of industries are represented now. So what I want you to do is we're going to go back to the slide before. So if you'll back up to the risk times severity times likelihood, I want you to think about your industry and what factors impact severity and likelihood. So I'm going to wait 15 seconds for you to jot down what impacts severity and likelihood. What are your big hitters?
Nancy, would you like them to post that in the chat?
That's an excellent idea. Type in your industry and your top consideration for severity or likelihood in the chat. And I'll give you an example. For pharmaceutical industry, we look at hazards toxicity, making toxicity a way and a reason that we not only exposure band, but we also control band, because toxicity is what it's all about. And by doing risk assessment, we can knock out the lower toxicity compounds and save a lot of money by not giving them a lot of attention, but really focusing on those higher toxicity compounds. Okay. So you want to read off some of those responses?
Yeah, so we have one from David Duncan mentioning the chemicals and length of exposure. Not exactly sure what the industry is.
Okay. Well, that's a pretty common one because chemical toxicity is a major concern for industrial hygiene in a lot of industries.
We have another one for education with research, what material they're using and toxicity and length of time.
Yes. Yep, exactly. And you find a lot of variety, especially in the higher education industry where you have research institutions where it's almost like the Wild West because everything that they're doing is R&D. This is true in pharma as well. Because everything is new, you don't necessarily know what the hazards are going into it. And so risk assessment becomes very important in order for you to give those that are working with these new materials a guide for how they can safely work with them on a daily basis.
We have another one with petrochemicals. So petrochemicals, toxicity, frequency and duration, and level of controls currently in place.
Right, very good. Okay, we'll go on to the slide that's past group exercise that's entitled Anatomy of a Risk Assessment Tool. This should look very familiar to many of you, where you're looking at the likelihood of harm versus the severity, and you're basically color coding for low, medium, high risk, very high risk, depending on how far out you feel compelled to go. When you can do this, it gives you a color coding for where you're going to pay attention. And you realize that you're going to have different responses for medium risk and high risk for exposure assessments and controls according to that risk assignment. And so having an outcome like this not only gives a pictorial and a good snapshot of where you need to pay attention, but it's also a good communication tool because these kinds of approaches are used in many facets of a business. This is not a new language to other parts of our businesses. Next slide. What we're going to do is go through an example of a risk assessment tool that I've used in cement industry. When I worked for Lafarge Wholesome, we did focus on cement production. Our main risks that we identified, especially in cement production, are silica, respirable dust, including cement powder, because of other hazards within that respirable dust, and noise. And what we did is we provide risk ratings for 17 possible different areas in a cement plant. So you're going through your whole process and you're saying, well, it's not just one big cement plant. You have to break it down into potential areas where you have production going on. And what this does is it provides an overview of that whole process, which makes it turns it into an exercise in knowing your process. And I think doing risk assessment, one of the main benefits to industrial hygienists is it forces you to systematically learn every aspect of your process. And I don't know what you were told in school, but I had a ventilation engineering professor at Michigan who said, if you don't know your process, you don't know anything, and really drove that point home. So learning and creating an overview of your process and the materials within gives you the larger picture of what's going on. It also assesses the worker's risk potential based on past exposure measurements, because maybe you do have some quantitative data, and best judgment, which is a qualitative approach. So it's combining quantitative and qualitative input in order to make good judgments on where your risk is. Okay, next slide. So in this tool, step one is to look at the testing history. Do we have any background information or data on worker exposure levels that were actually taken with qualitative exposure assessments? If we have that testing data, great, we put that in. Step two is to look at a qualitative assessment where you're looking at your process materials, you're looking at emission severity, and in this case, we're going to go through dust, looking at duration of exposure, which worker groups are affected. Is it operators? Is it maintenance? Who's being impacted? And then looking, do we already have existing controls? Do we already have some things in place, or is it completely without control at this point? Then once you've put that data on, the output then helps you decide what controls you might look at in order to bring a high risk to a medium or to a low risk. And usually there's guidance by the software to the user on selection of appropriate levels of control based on those risk ratings. And this is where it ties into control banding, where you're taking it from exposure banding to control banding based on subsets of risk. Okay, next slide. Here we're getting into a picture of the actual tool. And like I said, in sheet 1, step 1, you're basically putting in background information and you're reading through the directions. So for whatever tool you develop, make sure you give good directions, or you develop a handbook for how to put the data in, and you make it as simple as possible. Those are probably the biggest points that create hiccups in use of these tools, because you're creating these tools for your peers to use in the field. And so not only do you need their input while you develop them, but you also need to provide guidance while they use them in the field. So after you've put in background information, next slide, you're going to identify the plant areas. Now, instead of you looking at the minutia, which you may or may not be able to read in this, what I want you to focus on is this main header that is colored, where it goes from process and work task dust emissions. And then in the yellow box, it identifies sources and locations. Then it says types of materials. And these are input, where you have drop-down menus that will allow you to pick the crystalline silica content of the material in this case. And then it's going to ask, do you have visible airborne dust? And can you rate this? So this is qualitative. Then spillage cleanup amounts. Does this process have a lot of spillage? Again, you're going to give it a qualitative rating for how much spillage is occurring. Then you're going to talk about the maximum worker exposure duration. So you're going to pick a category of time. Is the worker exposed less than an hour? Are they exposed half a day? Are they exposed for a full day? And then that's the only input that you're putting in, besides if you have it here at step 1 where you've put in your exposure assessment data at the very top. And what this sheet does is it takes the data from step 1, exposure assessment, giving it a risk, the data from the 4 pink columns where you've put in data, the crystalline silica content, the visible airborne dust, spillage cleanup amounts, and maximum worker exposure duration. Those are the only inputs that the user has to put in, and it will calculate what those risk ratings are in the next step. Okay, so when you develop these, you want to make them as simple as possible with as concise data as possible, where the user is simply clicking on a drop-down menu and they're picking ranges of things, ranges of visible airborne dust, ranges of duration, and so on. Now, you're in this case with crystalline silica, that exact silica content is not only heavily weighted, but it's critically important because respirable crystalline silica is a carcinogen. So getting that number correct tends to be a narrower range. So once you've put this data in, we'll go on to the next slide.
Nancy, what slide are you on?
I am on slide 13, and it's highlighting step 1, where step 1 you've put in the air testing data from the past, worker dust exposure levels, and then where noise is concerned, area noise mapping completed, personal noise testing completed. And these weigh into what the risk is, because if you've done nothing, then your qualitative data becomes more heavily weighted in terms of determining risk. And feel free to type in any questions that you might have in the chat, and if you guys can let me know if there's a chat question. So once they put in step 1, and then we'll go on to next slide 14, which is step 2. Like I said, you're putting in 4 sets of information, just focusing on dust emissions right now. You do the same thing for noise emissions. And then other agents can be added to this. And feel free to use this as a template for designing your own. And then the next slide, 15, again, enlarges what I covered before, where you're putting in visible dust, spillage amounts, maximum worker duration. And those are all drop-down menus. Going on to slide 16, you're going to fill in, you're going to tick the boxes for which workers are affected, and you're going to tick the boxes for existing controls. So if it affects workers that are in production, maintenance, labor, vehicles, or other, you're going to tick those boxes. And these are just for reference farther down the road. And then existing controls. Do you have engineering containment? Do you have engineered dust collection? Do you have engineered bulk? Do you have cabs and booths to enclose the worker? And so on. So wherever you have controls, you can tick those boxes to get credit as well, because those all impact what your risk is. Then slide 17 is sheet 2. So once you've put in information, this provides you criteria for selecting the correct inputs in the worksheet. So in this case, like I said at the very beginning of this, you provide the person filling this out some guidance for what they're going to put as input. So this is a guidance sheet. Slide 18, output. All right, so now you've put in what the user needs to put in, and now it's going to give you risk levels. So in these sheets, it's going to start giving you color-coded risk levels so that now you can look at your larger process and figure out what you ought to be paying attention to, because it's rated very high risk, maybe even medium risk for your longer-term priorities. And output elements of the tool giving you risk levels. It provides banded levels of recommended controls that you get directed to based on those risk levels. So you can add into these sheets a way to direct the risk toward what controls would be recommended based on that risk for that particular process. I've developed these kinds of tools as well for pandemic, where you can evaluate a building's facility pandemic resilience. So using that as an example, and I'll pause right here, when you look at pandemic risk in a building, you're looking at the building's age, the condition of its ventilation system, what kinds of filtration are inside that ventilation system, how many air changes per hour, hearkening to the previous lecture. You're looking at the age of the occupants. You're looking at whether your ventilation system has a building automation system to control that ventilation rate. So you're looking at all of the input that you would put in, and then you get output rating the risk of that process, of that facility, that will then direct you toward what are your solutions? And that's what we're getting into now. So slide 20, it directs you in the cement industry. It directed us towards spillage control options. So whether you're level 1, 2, 3, or 4, for how bad things were. It gave you ideas for how you would fix the problem to bring your risk under better control. So this is like a banding process and spills over into what Brad's going to talk to next, where you basically set up buckets of controls. You're setting up buckets of how you're going to respond based on how bad it is. So they're grouped in this case for fugitive dust and spillage. And for each location, the recommended control levels cross-referenced from the previous sheets. And the tool should direct the user toward what the solutions are, because it's not enough to just know how bad your risk is. You also need to know, what are you going to do to fix it? What are you going to do to bring it under control? Next slide, 21. This gives you a pictorial of an example in a risk summary. And in these risk summaries, at the top, we have one for silica and respirable dust. And then to the right, we have one for noise. And basically, it tells me how many locations in a facility are very high, how many are high, how many moderate, and how many are low.
Nancy,
So
I'm sorry, I'm going to interrupt you. My slide 21 is discussion and review of your industry. Can you give me a title? What are we supposed to do?
Oh gosh.
Yeah.
Yeah, output elements of the tool.
Okay, that's 19 for me.
Oh gosh. Oh, you know what? It could be that we skipped a couple of slides. Oh, okay.
I think
Anyway,
we've been okay until here.
Okay, output elements of the tool. So on the left, you have some text, and on the right, you have risk summaries. The risk summaries are for silica and respirable dust, and then the one on the right is a risk summary for noise. And it gives you a snapshot of your facility. And this is really your communication tool that you're going to take back to the other decision makers, the people who hold the capital budgets, the people who hold production schedules, and are going to help you make decisions about what you're going to address, when you're going to address it, and how much money you have to address it. And these speak volumes to those people that are in those positions, because it gives you color coding to say, at this facility, I have one location that's ranked very high risk and 3 more that are ranked high. That's where we need to focus our money. We need to focus our CapEx budget. And it gives you ratings that are not only pictorial and color-coded, but you can also dig back through the numbers, and you can show them what the score was and what the criterion was in order to come up with that key performance indice. So these color codings actually become KPIs, the numbers that are associated. And it's hard to read on this, but like the risk KPI is now 46.1 for location-specific risk ratings for silica and respirable dust. You use that number as a benchmark. So if you address and improve those very high-risk areas and those high-risk areas, 4 in total, and you make the improvements and you bring them down into lower moderate, that risk KPI will change. It will improve. And so now you have a number to benchmark against. And it's another KPI that can be incorporated just as we have safety KPIs. And when you think about it, in industrial hygiene, we don't really have KPIs. But if you do risk assessment, you can create them and create numbers against which you can benchmark from year to year. And within the pharmaceutical industry and within the cement industry, I had tremendous success with this because it speaks the language of people who are in management with me, and it also gives me a way to track my progress. So next slide. So working through an example for industry, we're going to move on to slide 23 that's entitled Discussion and Review of Your Industry. So this is a group exercise, and it's also an individual exercise. I put this in here so that if you take these slides and you decide to develop a risk assessment tool for your own industry, and it doesn't have to be as sophisticated as the one that I've shown you, it takes you through what steps you're going to do in order to develop that. You're going to list your work areas. You're going to list the sources of a hazard for one work area and the top factors for severity and likelihood. And then you're also going to list the kinds of workers that are impacted in that work area. And then you're going to take the information back to your company and other work areas and create your own tool. And at first, when you go through this process, it feels daunting, but I can assure you that as you get into it, you start to realize that it's not that hard, first of all. And second of all, you're learning at a very granular level your process, and you're also elevating your mind to a much higher level to see the big picture. Next slide. Within doing risk assessment, you do have some design considerations. You have to think about the relevance and the value to multiple levels of your management, okay? That's a selling point. The value is, to me, in creating KPIs and gaining the bigger picture of where your systems and your processes are, identifying your highest risks, so you know where to direct your resources, is very, very relevant and very, very valuable. It needs to be usable by non-IH professionals while still obtaining valid output. Obviously, none of our organizations have enough industrial hygienists to be running around doing risk assessment data input. Usually, if you design these correctly, they can be filled out by the people that are in operations, okay? They can tell you what percent silica, for instance, is in the process. They can tell you how long a worker's exposed and so on. They also need to be user-friendly interface. Like I said, don't forget to include instructions. Don't forget to give them options. Don't forget to not include drop-down menus to make life easier so that you have minimal input effort and a high degree of auto-completion of those fields. And first and foremost, don't use big words. And you need to make it understandable to users who maybe their language is not English. I've rolled these out in global operations where English is obviously the business language, but it's not the first language. The smaller words you use, the better, or the higher the likelihood is that it'll not only be palatable, but it will actually get done. Next slide, implementation for global rollout. If you are looking at global rollout or even regional rollout, multiple site rollout, make sure that you get management awareness and endorsement. Always get approval from above, support from above before you roll something like this out. Tool technical support. I've seen my tools get turned into beautiful software apps that end up on people's phones, and all they have to do is click on a multiple choice question, and then the output comes out from there. So if you can get technical support to convert this to something even easier than an Excel spreadsheet on steroids, that's great. Make sure you develop a communication plan so that people know before you create the expectation what it is that you're rolling out, okay? And then offer training to support them in filling it out. Even if it's a software app on a phone, people still need to understand what it is that you want them to do, and you're going to train them so that the quality of your data is as high as possible. And then data collection and KPI interpretation should be done at your level or higher. It is a group exercise. It should not be done by an individual. more heads are better than one. So make sure it's a team that provides input on what kind of data and what the interpretation of that data is. Two, the more people that you involve and the more forward planning that you engage in, the more likely that it's going to get traction in becoming an official key performance indice. Become part of capital budget planning and forward planning. Okay, so the more the merrier. Slide 26, the challenges. Often with these tools, you have to control the evolution. Trust me, you'll get people saying, gee, you could have worded this better. Gee, you could have rated this better. Gee, I don't like this output. Well, after you've developed it, beta tested it, and proved, through a validation process, however complicated you want to make it, that it works, control that evolution by reassuring people that you will update it, but you're only going to periodically update it, and that it's good enough for the time being. Okay, that's the bottom line. Because if you let people encourage you to continually evolve it and continually update it, you end up with different versions out there and you end up with an out of control tool. Make sure you get continued management support. That's often through keeping those KPIs abreast and management discussions and decisions. And make sure you change the management plan accordingly. KPIs can be good news or they can be bad news. But I think most people in upper management take them for what they are. So it's just a number when you come up with that risk rating for a process, and it's a benchmark. So it's not necessarily good or bad, it's just something to benchmark again. And so that needs to be your talking point. And that's all I have for this lecture, and the last slide gives you some contact information. Like I said, if you want a copy of my slides, it'll either get provided through this group, or if you want to contact me directly, you're welcome to. I'd be happy to answer any questions that you might have as you go along, and maybe you're in the midst of developing your own tool in order to do risk assessment.
Nancy, thank you. I think that was a great presentation, and thanks for sharing, your experience with this, a very important topic, something that, all industrial hygienists need to be involved in, and obviously more involved in management and helping with those decisions that impact organizations. Looks like we've got some questions coming in, and first one is, what are your thoughts on software such as Corti?
Yeah, I like Corti for data management. I became familiar with Corti while I was at Lafarge Holcim. They offer a very comprehensive approach to industrial hygiene data management, and it's another way to do risk assessment. But it's an investment. I think that caveat is important. Not every organization can afford the price tag that's on a Corti system, but it's one way of doing it. The approach that I've described to you is more homemade. It's more organic. It's already customized because you developed it. Whereas if you buy an off-the-shelf package like Corti, you're still going to have to customize that for your organization, for your hazards. So sometimes you're better off developing your own. It just depends on the level of sophistication that you'd like in your system.
Great. We have another question, and I imagine you were expecting this one. Obviously, many are interested in getting copies of your slides, but even getting a copy of your assessment tool.
I'll have to check with the originator. Sometimes I can turn loose of tools if they're like 6 generations old. I can check on that because I can appreciate it. The algorithm that's behind it looks more complicated than it is. And now that I've developed several of these, It just depends on the level of sophistication that you want your tool to calculate, but it's not as hard as it looks. If you have somebody who's good at Excel, and for instance, when I worked in pharma, I had a young lady that I still refer to as my Excel queen, and she would play with the algorithm behind the tool, and she would tweak it as we needed tweaking. With the cement one, it was developed by another industrial hygienist that was a consultant to Lafarge Wholesome, and he would tweak it behind the scenes. And then for the one that I just developed for facility pandemic resilience, I consulted with an engineer that was really good at Excel. So if you can pair with an engineer or somebody who's really good at Excel, you should have no trouble whatsoever developing a tool in-house that will do exactly what I explained.
Yeah, I'd like to, add on there. So for those that maybe are new to this and want to get more involved in doing these types of risk assessments, is there a good starting point you would recommend? Some maybe some books that could help, that they could read up on it, or some websites that would have more information on
there's
tools.
There's AIHA references if you get in and search under risk assessment. In terms of actual tools, though, it's like no one wants to turn loose of their tools. But really, I'm very sincere in saying that if you, as an industrial hygienist, pair off with somebody who likes Excel, you will succeed at building your own tool, because that Excel person will actually laugh at you when you suggest to them that this is hard. All you have to do is tell them what you want it to do, and they can do it a lot easier than you think, okay?
Yeah, I think from my own experience, and you made a good point, Nancy, on, they've been doing a lot of this in safety for some time. So I know some of the safety resources. I think Brower has safety and health for engineers. They cover a little bit on risk assessment and some of those algorithms. So just so for some of you, just to get an idea of how you can build your own algorithm, for those types of calculations. I know they have one for noise.
Right.
And so, but yeah, I think for most, it's really a matter of researching the topic, going to those resources that we talk about risk assessment, and once you're more comfortable with it, it's not so bad.
Yeah, if you get the white book, or we lovingly call it the Bible, that's the AIHA white book for industrial hygiene. There's a good section in there on risk assessment that will provide guide. But quite truthfully, you just simply need to think about your industry. What are the tasks? What are the hazards? Feel free to use the headings that I've used in the tool on the slides that I've shown you, and just start tinkering with it. And trust me, that the picture will come clear to you what should be included in your risk assessment. And then as far as weighting and creating that calculation that's in your Excel spreadsheet, any good engineer will be able to help you. And I recommend that you make it multiplicative, not additive, because if you give its weightings by multiplying factors rather than adding factors, it gives you a better spread. That was really the only trick that I discovered in developing my own.
Great. Well,
And I have colleagues too that will come alongside if you want to hire somebody as a consultant. My dance card's pretty full these days, but I know of consultants that can come alongside at a very reasonable rate and help you if you need help. So.
Excellent. I don't see any other questions. So thank you. Thanks again. It's a great presentation.
You're
There
welcome.
were some positive comments on your presentation, so
Okay,
very
great.
informative. Thank you.
Great. Well, I know Brad will do a great job at the next part, which is exposure and control banding, which goes a long way from taking information from a risk assessment and then applying it to those solutions, especially when we don't have occupational exposure levels and don't have a lot of guidance on especially highly hazardous materials. So thank you very much, and I'll look forward to hearing Brad's presentation.
Thank you.
Thank you, Nancy. So we're just going to take a quick break and give Brad a few minutes to get set up, and then we'll get kicked off.
And Michelle, I'm set and ready whenever, but if folks need a little stretch break or what have you, we can wait a few minutes.
Sure, let's just take a few minutes. We're running a little early, which is fine. So yeah, let's just take a few minutes, take a stretch break, and let's come back at 10:50 a.m. Central Time. And in the meantime, Brad, I passed the share ball to you, so you should be able to share your presentation if you want to go ahead and try to pull that up. I can see it perfectly. Good deal. All right. So welcome back, everyone. We have with us the last presenter of the day, Mr. Brad Jones, who is an industrial hygienist at Lyondell Basell. Did I say that right?
Yes, ma'am.
Okay, and Lake Charles, Louisiana. And Brad is going to follow up on Nancy's presentation talking about occupational exposure banding, the IH risk assessment approach, in the absence of OEL. So, Brad, I'll let you take it away, and thank you for being with us today.
Thank you. And I started off with a video just so folks can put a face with a name. Thank you for the introduction, and thank you to the group for inviting me to speak and to share. And a great segue from Nancy's discussion, and she put a little pressure on me, saying, you know, hey, she knows I'm going to have a great presentation, so I hope she didn't jinx me. Anyway, we'll move along here. I'm going to stop the video and just focus in here on the presentation. So just a little bit back up, just a quick piece about myself. I've been an industrial hygienist for the last 25 years or so. I've been pretty much the boots on the ground type of hygienist, working in petrochem and refining. About half of my career has been in industry, working directly as an industrial hygienist for a particular company or manufacturer, and then the other half has been in consulting. So I've not decided, you know, which one I want to be, I guess, when I grow up, whether it's a consultant or plant hygienist. But one of the things that I do love about our field in industrial hygiene, one of the things I learned when I first started 25 years ago, I was introduced to this concept of qualitative exposure assessment. And ever since then, I've had a passion for that and learning how to apply that in facilities. So, you know, this occupational exposure banding is a great fit into that passion. Today, our learning objectives, I want to give you we can really get down in the weeds with occupational exposure banding, the NIOSH methodology that I'm going to talk about today. But because we are limited on time and it can be overwhelming, I'm going to give kind of a 30,000 foot overview, and hopefully it's enough to to meet these objectives. We'll have a basic understanding of the NIOSH process, understand the limitations of this process, and then what are some ways that we can look at applying it into our other risk assessment practices, as Nancy had discussed, you know, developing that framework. As I was listening to her, you know, I was thinking of a lot of the things through the years that as I've matured and further developed in my exposure assessment processes and understanding and seeing new tools along the way. How you add on and how you help kind of create your homegrown system and how you expand it. So, you know, I'll throw out some ideas and even, you know, look for some ideas from others if you've used this tool in the past. I don't know if I can see the thumbs up, but I guess just before I get started, I want to pose a question, and you can just do a thumbs up in the chat. And if somebody can, I don't guess I can see the chat the way I've got this set now, but my question is anybody that's on the call today actively using occupational exposure banding in any of their work? Or are they just, yeah, is anybody actually using this process?
I'll monitor the chat for you, Brad.
Okay, thank you.
So far, nothing.
Okay. Well, that I've got this month's issue of the Synergist in front of me, and I grabbed it because it was perfect timing leading into this discussion today. And if you get the AIHA publication, you know, this publication, there's a great little one pager from Dr. Mulhausen, who's the current AIHA president, and the title of the article is Occupational Exposure Banding, No More Excuses. And a couple of things I highlighted just looking through here, and I want to kind of just preface this presentation with that is, you know, it says, fortunately, there's an effective approach that exists for chemicals that don't have an occupational exposure limit. He says, but distressingly, few OEHS professionals are taking advantage of it. He talks about the e-tool that I'm going to talk about in a little bit. And a lot of his colleagues in different conversations he's been in, by and large, the feedback he gets is that most of the professionals indicate that they have no plans to incorporate exposure banding. And he kind of, throws the gauntlet down and says, why not? It's a tool in our tool bag. And many of the responses that he had received was that, well, he really broke it down to 3 different responses. One was that OSHA doesn't require it. And I'll just say, at the risk of, I don't think I'm offending anybody on this call, but I would share with any colleague that came to me and said, well, OSHA doesn't require it, say, well, we've got a duty to protect our employees and to go above and beyond. And if we look at just OSHA and what OSHA requires, we can all agree that there's outdated PELs out there. I mean, they adopted the 1969 TLVs for the PELs, and let's face it, there's not been a whole lot of update there. So we really need to be going above and beyond in what we look at and using other trusted sources like TLVs and more current data. And the other response was that, hey, this exposure banding process is only for the most distinguished experts. And I will admit, when I first looked at this years ago, when it started getting introduced and I started kind of looking at it, I thought, oh, it's kind of over my head. I don't have time to dig into that. But this latest iteration of the e-tool that I'm going to just show you a brief snapshot of, they've really made NIOSH has done a great job in providing us a tool that's very user-friendly for somebody that doesn't have a lot of toxicology experience, which is kind of where this exposure banding leads to. And then lastly, one of the responses was that I don't see it being done routinely in major organizations. And again, I would challenge the status quo and say, who cares if you don't see it in a major organization? Here's a tool for our tool bag. And if just because another major corporation isn't using it, why don't let somebody be the trendsetter and step forth in it? So I say all that to say that, as a disclaimer, the company that I work for, we are not right now actively we haven't integrated occupational exposure banding into our health risk assessment processes. I did introduce it internally to our health and safety network. We have monthly meetings, and I had an opportunity to share about this topic, and it was met with a lot of positivity, and there's some discussion going on in the background that I'm hopeful that we can through some time and some discussions develop or integrate the occupational exposure banding process into our risk assessment process. But right now, we are not a company that's actively using it. I've got some examples that I've used in my consulting days, so I have applied it in some cases. But with that, I'm going to move on. I just wanted to share that little tidbit from the synergist because I thought it was a great opening to what I'm going to discuss today and why I'm going to discuss it.
Brad, there was a few discussions in the chat just indicating that limited use of exposure banding, mostly SCGs or similar exposure groups, but there's definitely interest. I'm seeing that interest in the chat.
Okay, good. Yeah, I think what I run into with some of the colleagues I speak to, they just haven't taken the time to research it. And the other thought, I'm sorry if I'm kind of all over the map, but I think there's several contributing factors here for the lack of using it. One is not being able to take the time, and that we as hygienists as a whole, we're wearing numerous hats. We're health and safety professionals, or we're hygiene professionals with limited staff and limited capability, and there are just so many other priorities that we're stretched thin as well to really dig into this. But one of my plans and my personal goal is to take this and slowly kind of scatter some seed around and hopefully to further this and get it integrated into our company for use. So first question I'll ask, and this kind of goes back to some of the resources, how many folks are familiar with AIHA's resource, a strategy for assessing and managing occupational exposures? I know Nancy referred to the White Book, which is the Bible for IH, basically, and but this is another. There's in the chapter or two that's in the White Book covers some of this stuff, but in this particular resource, and there's a third or fourth edition out now, and it's just chock full of useful information. Some things. Thank you, David. I see that you popped up. Said the fourth edition's out now. I was just looking at the third edition on my bookshelf, but in my early days, I used that, and there's just a lot of different information there of how to go through a risk assessment process and what's involved in that. Not only from a quantitative standpoint, but really backing up and looking at things qualitatively, which I'll discuss in just a moment. The bread and butter of IH is, again, anticipation, recognition, evaluation, control. And when we get into this risk assessment portion, what I found early on in my career was when I think qualitative assessment processes were fairly new to the industry, a lot of people weren't doing that. They had loads and loads of data. And especially in the refining and petrochem industry, folks that you really saw them focus on benzene, butadiene, ethylene oxide, some of the heavy hitters, but because they had to, because of specific OSHA standards for those chemicals, or that was the known, the very well-known hazard that was a carcinogen they were trying to protect against. But this whole idea of qualitative risk assessment, introduced a qualitative or a holistic approach and systematic approach to look at all the IH stressors. And we're just going to focus on chemicals today, but it really provides an avenue to look at hazard severity, frequency, and duration of the task, what controls are in place, and develop a risk priority to put your budget dollars, use them the best that you can, given how you've prioritized the risk. So a great tool. This is just kind of overviews from the one of the past exposure risk assessment, some exposure risk assessment model through one of the working groups out there, maybe through AIHA, but it's a commonly found snapshot, and I'm not going to go through each of the elements, but this is really something I'm kind of counting on most of us being somewhat familiar with, that we go through and we do some sort of anticipation and recognition of the risk. In that, we're looking at the severity of the hazard, the severity of the chemical. Is it a carcinogen? Is it a skin sensitizer? Is it just a mild irritant? And somehow ranking that, and then along with frequency and duration, those are big factors in potential risk for a health exposure or health issue, injury, or illness related to a chemical. And then how's it controlled? Is it all enclosed process? Are there points in the process? Or like in my industry, the chemical industry, going and collecting a process sample. Some things they open up the atmosphere and let it flow into an open top jar. In a lot of cases, we're very well controlled with regard to carcinogens, and we have closed loop sampling systems that reduce the risk. So, you evaluate all that, come up with and we've got some semi-quantitative formula in the background that helps us take those criteria. And even, the AIHA tool I referenced, or resource I referenced, there's even some scoring for uncertainty. So, you can go ahead and figure in as far as some of your professional judgment. Hey, this is what I'm gathering right now. And this is what I have. I'm a little uncertain about this. So you're going to kind of sway the assessment, a certain way and make it a bit more conservative so that you maybe push it into a higher risk category. And through all this, we gather that, set our risks, develop our sampling plan, and go in, implement that sampling plan. And that qualitative assessment is evergreen, or should be something we're looking at on a regular basis and always looking to enhance it. Now, the challenge is, obviously with chemicals, I know as a hygienist early on, I'm plugging away and I'm overwhelmed with the number of chemicals and tasks. I'm creating my Excel spreadsheet and talking with operators and maintenance folks out in the plant, gathering my data, and then I run across a chemical that they deal with, and I go look at the safety data sheet and it says no occupational exposure limits exist. Yeah, well, this, and it's listing some hazards, but what do I do with that? As a hygienist, we like data. One of the things I loved being drawn to the profession was, hey, I go collect data, I compare it to a number, and you're either above or below, or you're close, and you're able to make some good decisions based on data. But then it was kind of a slap in the face. It's like, what? There's chemicals out there that don't have exposure limits, and I think this slide is a great illustration. And there's approximately 85,000, probably more than that now, chemicals in commerce, but there's only 1,000 of those, about 1,000 with authoritative OELs. And when I refer to authoritative OELs, I'm talking, obviously OSHA PELs or ACHRAE TOVs or even the NIOSH recommended limits, and even easing into some of the German MACs and others that are out there. But all those, in totality, there's only about 1,000 authoritative OELs to draw from. So we're left with a question. A lot of times we, as hygienists, we love traditional OELs. It's a quick answer to our question of how hazardous is this? Oh, it's got a very low exposure limit, something I need to take a look at. But the famous philosopher, Mick Jagger, I think he puts it very well here. He says, you can't always get what you want, but if you try sometimes, you might just find you get what you need. So hopefully you'll sing that to yourself. I've given this before and I've sang it. I'm not going to do that today, and let you know why I'm a hygienist instead of a rock band singer. But hopefully that song gets stuck in your head today. Moving along, I've talked about the tool bag. There's a lot of different things that we pull from to look at hazards. So, with the introduction of the GHS system, we have GHS classifications, engineering controls, look at PPE, we look at hazard communication and SDSs. We have exposure monitoring data. We have that coupled with medical surveillance data that's being taken to assess the biological burden on an employee. We have our exposure monitoring, our quantitative risk assessments. We have OELs. And this is just, occupational exposure bands are just another tool to add to the tool bag in the absence of an OEL. So the thing I like about this, when you really get to researching it and reading into it and understanding the nuts and bolts of occupational exposure banding, is that it, more than anything, I think the age-old question, there was maybe a misconception out there that, if a chemical doesn't have an OEL, then it's not that hazardous. It's not toxic. It's not something we should worry about. And I'll admit, early in my career, as a young pup in my career, I put a lot of things off to the side. They always nagged at me in the back of my head. It's like, well, should I look further into that? But I had no idea how. And now we have tools that can help us look at those things and not just simply ignore a chemical just because it doesn't have an OEL. The objective is just like these other when we talk risk assessment tools and stuff, a lot of what I heard Nancy say, I echo here. This whole exposure banding process provides a framework to systematically evaluate chemicals. And it's particularly targeted towards chemicals that don't have authoritative OELs. In fact, the documentation on the NIOSH technical report related to this and the tool tells you there's no need to use exposure banding. It's not appropriate to use it if there's already an authoritative OEL. So the value that it brings, it facilitates a quick evaluation. And we're going to talk about it's a tiered approach. There's tier 1, 2, and 3 in occupational exposure banding. And I'll be honest, I've hung out mostly in tier 1. I've dabbled with tier 2, and I've not touched tier 3. And you'll understand why when I get into those. But it helps us. It gives us a starting point where there is no OEL. This is a process that helps us give a rapid evaluation without having to have a whole lot of knowledge, and just knowing how to navigate the tool. And the tool is very, very simplistic to use. Helps us highlight areas where, hey, maybe we need more information. Maybe it highlights it just enough to say, this is based on this this exposure banding. This isn't anything I should be too terribly concerned with right now. I can push it on a lower priority, or hey, maybe I'll find out if it fits into a more significant exposure band, and then I need to give it some more attention. It can help us identify hazards to be evaluated for elimination or substitution. And one of the nice things, it's aligned with GHS. So starting to see some of these different tools and systems out there that are aligning with each other are nice. And I think that's the difficulty with exposure banding in general, is how to, we got to look at this, and then we have to make our own decisions and determinations and look at our existing risk assessment processes for industrial hygiene and how can this fit in there. And it's going to be a little different for folks. So this is just a big overview, or a big top look at exposure bands. So A through E, you see, you can either look at it in particulate and dust category or in the gas and vapor category. You see the ranges. So A is less hazardous and E is more hazardous. I already mentioned, that OSHA and other regulatory bodies, when there's already a limit, defer to those regulations or those authoritative OELs. Don't use this, but this is kind of the endpoint that we get to with a control band or an exposure banding process. And I'm going to kind of walk us through how we look at the processes to get us to determine where this falls in at. So it's organized by, and this is where the toxicology background comes in, but all of us have some basic, in industrial hygiene, we have to look at things based on the toxicity data as it relates to a respiratory system, or skin hazards and absorption issues, sensitization issues, eye damage. Is it an acute toxicity? Is there a specific target organ that it affects? So all these bands are assigned based on information that feeds into these 9 different toxicological endpoints. So here, this is a big picture overview. You've got tier 1, and it's very user-friendly. Health and safety generalists should be able to take this and run with it. It utilizes primarily the GHS hazard statements and categories to identify chemicals that have potential to cause irreversible health effects. And then, and the tool that I'll point to here in a little bit, I'll show you an example towards the end that shows some inputs that you place in there. And if the information this tool is connected to a couple different databases, and if the chemical is in that database, it'll pull that tox data in for you and go ahead and assign, make the selections for the GHS hazard statements and go ahead and give you a code. If a chemical isn't in there in that database, you can manually input that information, the GHS codes, into the tool, and then hit submit, and it gives you a hazard code. So very, very simplistic. You don't have to have a whole lot of knowledge and background on where all this information comes from. You're really relying on either the database that's connected to the tool or your safety data sheets, wherever you're getting that GHS information from. Tier 2, that's when you maybe dive a little deeper. Start looking at other data sources. So you really need somebody that's a little bit more advanced, because now you're looking at, with tier 2, you're looking at, it's basically a refining stage of the occupational exposure banding process. And then depending on where you get with that, you may need to do an even deeper dive. And most of the time, this is going to be a toxicologist or somebody that's a very experienced hygienist that, confident in their judgment, moving into this tier 3 and what they're looking at. So to break down this tier 1, tier 1, tier 2, first, the tier one, these are snapshots out of this technical report, and I reference it later in the presentation, and I make sure everybody gets a copy, again, either through this group or you can email me and I can send it. But first thing is to find a chemical. We identify a chemical without an OEL. If it doesn't have an OEL, then it can be banded in the tier one process. So then we need to determine, is it a dust or particulate, or is it a gas or vapor? And these are questions that pop up in the tool. You enter the name of the chemical and the CAS number, or one or the other, and it'll do a search in the database, see if it's there. If it's not, you select gas, vapor, dust, particulate. And then the step 3, that's where it's pulling from some different connected databases, or you input the GHS code into, from a safety data sheet or whatever resource you're pulling from. Then you compare those codes to each of the different health endpoints. And I'll be honest, I haven't went through and manually done this process. I've cheated and used the tool, but the tool is so user friendly, that it really takes all the guesswork out for you. So there is the long way around if you didn't want to use the tool, but the tool's there free for use. But then it assigns a band for each of the health points and ends up at the end of the day, it spits out a occupational exposure band that ranges, goes back to, it'll tell you in tier 1, it'll tell you whether it's C, D, or E. It won't assign a band of A or B in tier 1. And the reason being is that at this step, we're being very conservative in our approach. We're going to err on the side of safety and health and be a little bit more conservative in our judgments. So we start off in a tier 1, and we'll assign it will automatically assign it C, D, or E. Again, the GHS codes are what provide the basis for it. A lot of really low data requirements. I mentioned they can be banded in C, D, or E. They're really based on severity and reversibility of those effects, and it's a real tier 1 is a very useful screening tool, but tier 2 is recommended if data and expertise are available. I'm going to back up for just a minute, back to here. So just to kind of, if you can envision applying this, so I've went through a process and I've identified a chemical that didn't have an OEL, and it came out to be an exposure band of a D. The way I might use that is it all depends on your risk assessment process. So, I've seen a number of different variations, and when you're looking at hazard severity, some are looking at they maybe have 4 or 5 choices that range from, hey, this is a carcinogen, it can cause irreversible effects. It's really based on a description of the health effect or some variation thereof. I've seen risk assessment processes that take that in conjunction with plugging in an exposure limit. So if you've got an exposure limit range that's, if it's a gas or vapor with an exposure limit between, 0.1 and 10, then it might rank it might rank it a little higher of a risk within that system. So one that I've used is actually an AIHA tool that's out there, and there's some good things about it. There's some shortcomings with it, but it asks, you can plug in an exposure limit and vapor pressure for chemicals, and it will, and you give a judgment on the controls, and it'll pop in exposure ranking for you, or priority ranking, high, moderate, or low risk. And so the way I've used this is right, wrong, or indifferent. Say I found something with a exposure band of a D, I went ahead and used that AIHA risk assessment tool. And depending on, I made a judgment call. Did I want to use a lower limit of 0.01, or I'm sorry, 0.1, or do I want to use 1 part per million as the exposure limit? A lot of times I would be more conservative and I would say, okay, let's have a working exposure limit of 0.1 based on this data. And then I'd run it and let it run its priority ranking within the tool. I'm realizing now that I'm talking through this, it might have helped to show an example of that. So hopefully that makes sense, though, that it goes back to how your tool is built, or what process you're following, and what kind of data that you're basing your exposure risk assessments on, and how specifically, how are you looking at hazard severity? Are you basing it solely on an OEL? Is it solely on hazard severity from the standpoint of, this is a mild irritant versus a carcinogen, that sort of thing. So, and that was a very useful tool for me in my first application of occupational exposure banding to clients in consulting. I've had some local clients that I've done some qualitative exposure assessment for to help them frame up a sampling plan. And we ran across some chemicals that didn't have exposure limits. And they happened to be ones that were used on a pretty regular basis, a lot of frequency and duration. And so we opted to take a stab at applying the occupational exposure banding process. And it was a pretty significant finding that, they either popped out in between a moderate to high risk ranking or potential. And it drove us to either decide to try to pursue some exposure monitoring, or maybe just pursue additional information gathering, take a closer look at it. And the caveat there is if you establish, there's a lot more to establishing an internal working exposure limit that you got to consider. And then a lot of the laboratories, analytical labs, they're not necessarily, I don't want to say it's not cheap. It costs some money to establish an analytical method. So you go to, a particular IH lab and say, hey, can you help us develop an analytical method for this? And they're going to charge you, however much they're going to charge to develop an analytical method, test it, validate it, and use it. So there's a lot more that goes into making that judgment and how far you want to go. Sometimes you may find that it pops out into an exposure band of an E, which is your highest risk, and you just go straight to making some determinations of trying to eliminate or substitute a different chemical of lesser hazard. But if you're at a tier 1 and you come out with a C, C, D, or E occupational exposure band, and from here you've got to make a decision. Okay, I need to go a little further. I want to dive a little deeper and try to want to refine this and see just how right I am, or just how confident I am in the data that I'm pulling together here on this risk, this level of risk. So you kind of start off the same in tier 2, and the tool does this for you. It'll walk you through questions and pick the chemical state. And now we're starting to dive into some of the toxicity data, and this is where it takes some additional expertise. The tool itself is using, it's weighting, it's giving a score and weighting the different toxicological endpoints. And it's also basing it off where's this toxicology data coming from? Is it from a highly reputable source? Is it from a reputable source? Is it from a source that is acceptable but maybe questionable as far as what's supporting the data? So it takes all these different pieces into consideration. It's semi-quantitative, you could say, and it drives you to the same thing. At the end, there's each toxicological endpoint ends up being assigned what they call an endpoint determinant score. It's being scored, and then you add those scores together, and you jump to step 6 here. If the total determinant score, in this case, comes up to greater than 30, then you assign an overall tier 2 band based on the most stringent endpoint. And if it's less than 30, basically you're saying, okay, I really don't have enough information, or don't have enough confidence in the information that I've pulled here, and I need to move on to tier 3. Tier 2 is always recommended, but it's really useful when there's no GHS codes, and when tier 1 is, you're questioning the tier 1 analysis being incomplete or maybe insufficient to make a judgment call. Kind of talked through a lot of this. It does require some training in toxicology, have some basic understanding. You have to know, what resources, understand what readily available resources are out there and how those are judged within the exposure banding tool. You got to have some pretty sufficient data to back it up. So that's why it's judging against the data that you're pulling from and the source of the data. Pretty prescriptive, and but it gives you the potential to say you've judged something in tier 1 as a occupational band of E. You might be able to, with a thorough tier 2 assessment, you might be able to move it to a D or even a C. So you do have the opportunity to, as you take a further look, you may identify it as being a lesser risk than you originally thought. One thing I will say on the tier 1 and tier 2, a lot of people question, well, what kind of validity is there behind this tier 1 and tier 2 process? And one of the things, if you take a look at the technical report about the exposure banding process, you'll find that, I want to say, don't quote me, but I think I'm close on this. The tier 1 process, there were studies and done where they use things with OELs and did some other things just to test the system, say how close are they. And in the tier 1, I don't recall the number of different chemicals and validations that they did, but they found it was 91% or 92% accurate as far as getting in the ballpark of what an established OEL was for the chemical they applied. And then for tier 2, as you're diving down even deeper, that validity number came up to, I want to say it was 97 and 98%, if memory serves me right. Maybe Nancy can chime in the chat and support me on that if she's familiar with those numbers. But that's what I recall seeing. So it is a validated process.
I would agree with that, Brad. They did a very extensive validation process for these tools.
Right. Thank you. So, with those kind of numbers, 91, 92% for tier 1 and 97, 98% for tier 2, I just believe it's a great tool to use when you don't have an OEL. It does, again, tier 2 pulls from different authoritative databases. And now I took a shot at explaining this total determinant score that's based on some individual scores that they give the toxicological endpoints. And the nice thing is that it's done automatically in the e-tool. Here, this breaks it down a little bit more. So the endpoint, the individual scores that are applied, and then the total score. Again, if it's greater than 30, then you've got sufficient data to ban the chemical in one of the 5 groups. And if it's less than 30, you really need additional research needs to be conducted. You need to move on to tier 3. Tier 3, I'm not getting down in the weeds in tier 3. I'm just going to say that it requires expertise in toxicology. It's a really intense review. Again, it's required when there's insufficient data and there's not really any guidance. So you really need somebody that can really dig in deep down into the weeds in toxicology and help determine where do we need to judge this particular chemical. There is, although these were high levels of each of these tiers, when I share the reference to the technical report, I will say the technical report does a great job of getting down in the weeds on those different tiers. So, later on, towards the end, I'll be open to any questions and try to answer what I can. But this technical report is a very easy read. Sometimes you get some of these type of reports and they can be a little overwhelming trying to understand what you're following. But this is very well put together report for a guy like me that's I'm scientific in nature, but I'm not doctoral, so to speak. So I really got to have things in layman's terms to help me understand it. And it's a great technical report to help place things into perspective and help understand how you might push this. I didn't put any snapshots of the overall e-tool itself. I reference it here and encourage you to go to the source. And what happens is you sign up for an account and use your employer account, your email, and NIOSH doesn't sell your data or let any of it go. And I know that can be a concern if you're depending on what you're looking at, but the information is presumably protected, and it's stuff that you can log in. So for my company, for LyondellBasell, if I run across however many chemicals, I run across 10 or 15 chemicals in the coming year that I run this e-tool for, it'll save that data in there, and I can go back and refer to it and refine it, going from tier 1 to tier 2. So it'll give me a list of what I've looked at, and I don't have to redo that work or save it in another spreadsheet somewhere, somewhere separate. So it's a nice cloud-based, internet-based system, if you will. So this is, I'll leave you with this example, and this was one that I just recently ran through because the site that I'm working at, it's a fairly new site, and we just established a qualitative risk assessment. So I'm in the process of framing up my initial baseline sampling strategy in that. And one of the chemicals I ran across in our laboratory that's a reagent was 3-methoxypropylamine. I'm looking at the SDS, and it's something that they use semi-regularly. Excuse me. But it didn't have an OEL. So, well, okay, here's a great opportunity to go and take a look at this occupational exposure banding tool and apply it. And it was as simple as opening up, that tool, plugged in the chemical name and the CAS number. And actually, in this case, when I entered that and I hit submit, I said that, I wanted to look at it, vapor/gas as far as the physical state. It told me that the database, I told you it was connected to some different databases, said that chemical is not found in there. So that put the onus on me. I found a safety data sheet, one that I felt confident in, and I started plugging in the codes. I clicked on the different tabs for acute toxicity and selected the applicable code based on the SDS. And you can see individually, it tells you what band it falls into for each of these were the 4 endpoints that are affected, that this chemical affected. So acute toxicity, skin corrosion, irritation, serious eye damage, respiratory and skin sensitization. So really more of a skin sensitizer. So I plugged in those codes, and based on the GHS hazard code, it assigned it an endpoint band in this process. And then behind the scenes, I can't, the technical report gets into some detail of how they do that. I didn't get into that in this discussion here, but it's basically averaging me somehow. There's some formulas going on in the background that comes up with an overall recommended band. And so acute toxicity was a C, respiratory sensitization was a D, the other 2 were E. So it pushed it towards the E. So I have this overall recommended band for this particular chemical, the vapor range of less than or equal to 0.1. So that tells me, hey, this is a pretty this is something to be concerned with, a significant chemical. And it's one of those things that I put in our risk assessment. I'm going to take a closer look at it. I need to have a better understanding of how they're using it in the lab, really where they're using it as far. And I need to go back and revisit. I don't remember off the top of my head, but you know, is this one of those things they're using strictly in the lab hood? What's the quantities that they're using, the frequency and duration, and maybe use this vapor range. Say, okay, I'm going to take something that I'm going to assume a working exposure limit of 0.1 and take a shot plugging this into our company's risk assessment model, and just go a couple different approaches. But it's one of those things that I flagged because it is a very low exposure limit that's recommended, or exposure band, if you will. That you know, in this case, it rated it an E and put a high, you know, put a red flag for it, where something with a C is maybe a yellow flag, and I'm not going to put as much emphasis on that, but I might still look at it. There's still a lot of professional judgment. You got to figure out, you got to get pretty comfortable with the process and understand the nuts and bolts of it and what's going on in the background, and then how do you want to integrate it with your process. This is the technical report that I've been referencing. It's the title of it's the NIOSH Occupational Exposure Banning Process for Chemical Risk Management. So again, very well put together document, free and available to download. And I'm in the infancy. I'll admit I'm in the infancy of trying to work it in. I've taken some stabs and used it cautiously in my consulting days in a few places, and then I've recently transitioned back into industry. So now I'm having an opportunity to take an approach within the petrochemical industry, and fortunately my employer is supportive of using these tools, and not just going with the idea that, well, she doesn't require it, so we're not going to do it, or that shouldn't be a priority. They really take industrial hygiene seriously. I'm thankful for that I'm able to use this as a testing grounds, I guess, for that. And so I look forward to seeing how that shapes up and how I can even grow in my understanding of this process. But with that, that's again a 25 to 30,000 foot overview. Certainly open any questions. I've got my contact information here. You feel free to contact me, but at this point, I'll open it up to any questions that anyone has.
Yeah, thank you, Brad. That's great. Yes, please post your questions in the chat. I think we have a first one here, Brad. For inhalation of chemical gases or vapors, does exposure banning use the chemical's vapor pressure as part of the methodology?
I would have to look back into the technical report. I can't answer that off the top of my head. I think I'm pretty sure that vapor pressure is included in, as they're looking at the GHS codes. I think that's one of those things figured in there, but I think as you drill down into those tiered processes, you certainly keep that.
You're right, Brad.
Part of the
This
process.
is Nancy. The answer is yes.
Yeah. And then for me, so I did reference an AIHA tool, that asks for you to input, the exposure limit, the vapor pressure, different information. So if you come up with a band and you want to select a working exposure limit per se, say in this case for the 3-methoxypropylamine, I pick so I could go use that AIHA tool cautiously and say an OEL of 0.1 and look at the vapor pressure of that chemical and plug it in and use it, use that manually as part of my process as well.
I had a question, Brad. Do you know of any good workshops? Maybe Nancy can help too. Any good workshops out there for like practical hands-on experience using the tool?
Yeah, there's going to be several offerings.
Okay.
Sorry, Brad. Go ahead.
Yeah, I think if I'm not mistaken, I've seen some things offered through AIHA, and I don't know if there's other sources out there that offer this.
Yeah, AIHA will have a huge push in the upcoming years through either AIHCE, webinars, local section support like this to offer this topic. You're going to see this topic have some major traction going forward. Sitting on the board, I've been listening to this conversation. The fact that John Mulhausen is the president of AIHA right now also helps. But you're going to see huge presence of this topic and huge effort to teach and roll out examples in order that this become what's called standard of care, which means it'll become kind of a benchmark for how we operate as industrial hygienists. So it's very important that people pay attention to this, because you're going to see that this is how we will operate going forward in order to be considered competent industrial hygienists in industry.
Yeah, I'd like to add that I was just checking the AHCE, and it looks like they do have some exposure banding PDCs. So it looks like they do have some available. And I'd also like to say, as far as the that exposure assessment strategies book, I did a really good PDC through the AIHCE conference a few years ago, and they gave a copy of the book, and it was an excellent, I think, full day PDC. So, and the nice thing is it comes with a free copy of the book. I don't see any other questions here. I just wanted to say that, I mean, it's been a while since I've practiced out in the field as an industrial hygienist, but I sure wish I had a tool like this going back years, because there's so many instances I can just think back of where it was a challenge, you know, even if it was, you know, things that are still commonly here that I'm surprised that there aren't occupational exposure limits for some of these. I remember dealing with bisphenol A, you know, and having, you know, a lot of complaints, exposures. I mean, they were using epichlorohydrin along with it. So, I mean, obviously we controlled the epichlorohydrin. We were controlling the bisphenol A, but having a tool like this would have been a great help, you know. And so versus just wading through, you know, toxicology data and trying to make a proper determination, you know, on our own.
I think the eye opener for me was, you know, when I saw the 80 some odd thousand, 80 or 90 some odd thousand chemicals in commerce, and only 1,000 of those having exposure limits. And, you know, we as hygienists should raise an eyebrow and say, hey, there's a huge gap here that we need to at least have a tool like this to start pointing us in the right direction, and make some, you know, if not anything, a high level prioritization tool to say, okay, yeah, we need to pay attention to this one, or now we can put this one on the back burner, but not just simply write them off like I did earlier on in my career, and still, you know, I still end up with a laundry list of things that I'm trying to work into our process, but it's a learning curve, and trying to figure out how best to work this process into our existing health risk assessment process. I think I saw Jan had a question.
Yeah, I had done that exposure assessment registry a long time ago when it first rolled out through AIHA, and I think I've taken the test once or twice, and I think I'm supposed to take it again next year. They're still leaving it as free for now, but I was curious, do you think any, because that used Mulhausen's thing of the Bayesian statistics, and we used that program from, you know, him and Paul Hewitt about, you know, what exposure category it's in. Do you think any of this is ever going to be hooked up with that potentially, or I mean, I agree with Nancy. AIHA is going to do a big push on this, and this is going to roll out for some time to come. So I think
Yeah, I think it'll be interesting to see, you know, as Nancy pointed out, you know, the big push on this. And, you know, I think I think it's great that there'll be the big push, but we also, I hope that AIHA and other professionals that as we're pushing this, that we do couple it with the existing tools out there and continually refine. You know, I think we've got to get more hygienists, I think, using this tool and understanding how it fits in their existing risk assessment processes, or how they can add it in or integrate it in with it, and then see what the pros and cons or the challenges are and work through those as a profession to, you know, always refine it. But I think that's part of the problem. We get caught up in a way that works for us, and we're wearing so many hats and so many things on our plate that sometimes we don't move forward. So what I like that, you know, NIOSH has developed this tool and given us something to push forward, propel us, you know, into the next stage that we as hygienists need to be in. So I'm hopeful that they do that, but I can't speak to whether they will or not.
Gotcha. Agreed.
I mean, Brad, I mean, you think about it. I mean, how can you do a thorough risk assessment if, you know, you only have a handful of chemicals that have occupational exposure limits and you have nothing on the other ones? It becomes very difficult, you know.
Right.
I think Dennis had a question. Are there good exposure banding resources on the AIHA website?
No, there are some good ones on there, and you can get to
Oh, there are. Sorry.
Yeah.
And I know, Dennis, you're involved with setting some of the occupational exposure limits. You know, how do you think this coincides with, you know, that decision process used to set OELs?
Well, I think it's important because you know, there are so few OELs, and then one of the other things I was interested in is how well that match up to the current processes. Like, what's the relationship between the two? And we heard they're like a 90+ % agreement in you know, in of the in well 90% plus in agreement between the two. You know, the use of the tool and the existing OELs that we have. So anyway, I played with it a little bit, and you know, most of the stuff I ended up doing ended up with you know, D&E categories. You know, but anyhow.
Yeah, I find it interesting that, you know, would that be some kind of justification for setting OELs? You know, if we're doing these exposure banding and coming up with D's and E's, you know, would that be a good justification for, you know, efforts to establish OELs?
Yeah, we had given that some thought, and you know, where they talked about OEL lights, so to speak. And also, I was looking for a resource that perhaps people have gone through this process for a number of compounds, and, you know, what did they find? Like, so is there a list that, you know, that has been made public of compounds that have gone through the process and are already published somewhere?
Yeah, good points.
Yeah, I had wondered the same thing about folks that have already kind of went through this, and was there some sort of published list? And I hadn't found anything. I think, and I don't know if that's a liability issue or what, but it is nice that you know, from a standpoint of having your own account or login, and you can build one for your site is nice. But it'd be nice to see some of that. Because you're relying on each individual's input, although the tool does a lot of the work for you. If you do have to put the GHS codes in, you gotta have reliance on whoever's putting that data in that it is correct. So some validation, I guess, as some of those are being developed or processed in the tool.
Definitely. Michelle, is it possible for me to share my screen?
Yes, it is. Let me pass you the ball.
I think I have it. Is that showing?
Yes.
Okay, good. I was curious, during the presentation because I was mentioning bisphenol A, and I thought this was a good example. It's a study in JOEH that NIOSH did doing the occupational exposure banding for bisphenol A. And I just thought it was a really nice article. I kind of just highlighted a few things, but it shows how that tier 1, tier 2 process goes with establishing, one of those bands. And so it kind of walks through the process. So I thought this is an excellent article. It was 2019, the February issue of GOEH. So if you're interested in just that process, I thought this article did a very good job at going through the process and explaining it. And so you see that that pretty much even tier 1, tier 2, I think came up with the same answer. I was putting it into the band D, I think, but
We
Dr.
lost the
Phelan,
screen, Bob.
yeah, I don't know what
Oh.
happened. I lost your screen. Can you share that again, please?
yeah. Let me try screen 1.
There it is.
Does that work better?
Yeah.
Okay. But it does a good job walking through the process, explaining. Let me just go to some of the tables because I thought the tables were fairly useful. And you can get this through PubMed Central for free. I go down, so it does a good job at explaining, what Brad was covering, the exposure bands, and then they have their tier 1. So it looks like for bisphenol A, there wasn't really much data on acute toxicity you can see the hazard categories coming in and the hazard codes. And but you see that based on causing serious eye damage and then may cause allergic skin reaction, that there's some endpoints, some bands there that are designated. And then because of some reproductive toxicity, suspected damage to fertility, you can see an exposure band. So that looks like a lot of those main areas, those 9 that Brad was mentioning, are used to help set some of those bands. And then going to the
And ask again about
going to the tier 2, there's a lot that goes into that, so you can get a real appreciation for all the information that's going into establishing those exposure bands based on acute toxicity, skin corrosion, irritation, eye damage, respiratory sensitization, skin sensitization. So it actually looks like it's pulling data from probably PubChem, Hazard Substance Data Bank, various NIH resources, some of the REACH resources, some from all over the NIOSH skin profiles, and so, but there's quite a bit that goes into that, and so I just wanted to at least share that, and because I think it's important to have these tools, and it's a challenge for us as practicing industrial hygienists to actually evaluate these hazards if we don't have an occupational exposure limit readily available.
Thank you for that. Can you copy that link and put it in the chat?
Yeah, copy that. I just need to know how to just stop sharing.
If you hover on the top of your screen, you
I
should
see
see a little pull down. Yeah, there you go.
So I will post that in there.
Thank you.
And it looks like Brad also posted some NIOSH document related to the topic on exposure banding.
You should be able to directly copy that, but we'll make sure these links get sent out along with the recording and PDFs of presentations pending permission.
Great.
So did we have anything else for discussion or as far as, these presentations go? I think that was it. Okay.
I want to thank Dennis for getting it started with the distinguished speakers list and our brainstorming to start picking speakers and filling the slots. I want to give a plug for the joint ASSP, AIHA, the PDC. We're finalizing the agenda and the content for that. One track's going to be IH, track safety, and maybe even a safety Spanish speaking track. That is April 22nd of 2022. It is going to be face-to-face. It's at the Marriott South Airport. Michelle's going to do the CIH, CM point things. And so we're finalizing the agenda to get it submitted for points, both for the CIH and the CSP. And it is going to be a face-to-face event with exhibitors. So we're going to look at each other and talk technical and stuff. So that's going to be another great CE event. And then if anyone has any ideas for topics for our next council meeting, okay, I'm sorry, I keep calling it that. I live in the old days. Or other things, please share.
Thank you, Jan. Yeah, if anyone has any topics of interest or recommended speakers, or yourself, if you would like to co-produce an agenda with us, please either reach out to me by email, or you can enter those topics or speaker recommendations into the chat. We have a few minutes. Or you can email me, and I will put my email directly in this chat. I'm hoping that we can host another one of these in April. Usually we do the third Thursday. I'm keeping the momentum going from, the past GHIHC, where we do the third Thursday on even months. We haven't been able to do as many, but, given all kinds of situations. But the more people I can get to co-produce agendas and get speakers and topics, the more of these we can do. And for now, we will keep them online, at least for the spring, and then in summer, and then we're looking at the fall, trying to host at least one in person, and then, online following. And then, Jan, do you have a link to the PDC where people can go and check that out? If you want to copy that into the chat, please feel free while I wrap up. But as Jan said, the Southwest Center will be offering the CM points through CEUs for the Gulf Coast AIHA and Safety Professional Development Conference. So we are involved in the IH track. And there's
Michelle, I've posted it in there in the chat,
okay.
The link to the Gulf Coast section for AIHA, and it does have information on the PDC.
Good, thank you. All right, so I just have a few things to go through. Let me pull up my screen here. So again, I just want to take a minute to thank our speakers, Nancy, Brad, and Kristen, Dr. King. So, we wouldn't be able to do this without you. And then, of course, to our agenda producers, Jan and Dr. Casserly. And then special thanks to the board members of the Gulf Coast section of the AIHA for also co-producing this agenda. And then Dr. Phelan for co-moderating. Thank you so much for your service today. I don't know if everyone knows, fully about the Southwest Center for Occupational Environmental Health, so I just always like to give a quick shout out and tell you about our NIOSH Education Research Center. We are funded, of course, through CDC NIOSH, and we're here at the University of Texas Health Science Center at Houston School of Public Health. We have master's and PhD training programs, our graduate training programs, our outreach and continuing education programs, and then research and practice. And besides this, we, for CE, we do other events that you may be interested in. So if you just go to our website at www.swcoeh.org and scroll down to events and news, we always post our upcoming events through our webpage, and then that will take you to our training calendar. You can also follow us on our social media pages on Facebook, Twitter, and LinkedIn, and we also have a YouTube. So, just stay in touch. My email's in the chat. If you think of anything you'd like to know about, talk about, recommend speakers, topics, we're happy to discuss it. And, this wouldn't be possible without you all, our participants and our the Gulf Coast section of the AIHA. So I thank you for joining us today and always. We'll be sending out evaluations later today and then certificates of attendance on Friday or Monday. And that's all coming by email. And then, of course, again, the PDFs of presentations, and we'll have a recording available early next week. So you'll be getting a flurry of emails. So just stay tuned. And Dr. Phelan, did you have anything else to add?
Yeah, I'd just like to thank, University of Texas. You're a valuable resource to the area. It's important, especially with the CM and continuing education, with COVID and the way conferences have been going. We're all challenged with trying to maintain our relevance in the field and be updated and maintain our board certification. So that's very important. So I would urge everyone to, please let them know what are, important topics that need to be brought forward. And these all today were great, very relevant, excellent topics, things that we do need to be thinking about and getting involved in. And so I really appreciated today. It was a great session. And, but yes, please, make those recommendations, those suggestions, keep it going so that there can be more sessions like this, this year. So thank you.
Definitely. So thank you. And you can just reply. We'll put our emails in the emails that you're getting. You can reply directly to me or to our group email inbox, and that will get filtered to me eventually over the next couple days. So either way works. So thank you again, Dr. Phelan, Dr. Casserly, Jan, all of AIHA, to our guest speakers, and to all of our participants. And I hope you stay safe and stay well. Thank you.